In this one, let's take a look at an example of doing synthetic division. So we have the following. Divide negative x to the fourth plus 2x cubed plus 2x squared plus 2 by x plus 2. So let's set up the synthetic division. It works as follows. You're dividing by x plus 2. So in this box right here on the left side, you put negative 2. You always put the opposite of what you see. The reason, this is a bit of a technical detail, is the following, that when you say x plus 2, you can imagine that that really means following. X minus a negative 2. So it's really that negative 2 that goes in the box. Okay? A plus comes from doing minus and negative. So it's a negative 2 in the box. Then take a look at the next part. You see where it says negative x to the fourth? I'm going to rewrite that polynomial above the boxes so we can identify the pieces more cleanly. So first I'm going to put negative x to the fourth. In front of this negative x to the fourth is really a coefficient of negative 1, right here in this position. So here, this is negative 1, that's the coefficient. That goes in this box right here, negative 1. Whether you're doing it on a computer like this or by hand, it's the same thing. Then you've got your plus 2x cubed. So again, here, you're going to put 2x cubed. That 2 is what goes into this position right here, only that 2. So you're taking the coefficients only. Then you have that 2x squared, so that's 2x squared. Again, you copy that 2 into the box. Only that 2 and nothing else. Okay, into those boxes. Then notice that here, 2x squared is missing a term that contains x. We have x to the fourth, x cubed, x squared. We're missing x to the first. So in that case, you can just pretend that you stuff it in this position right here. You do that as plus 0 times x. And the coefficient then is 0. You put that in this box. You want these values here to represent coefficients from a polynomial that's from the highest degree to the lowest degree. It includes every degree, including x to the first. This one will be x to the first. So when you're missing a term, just stuff a 0 in there. So for example, here that means 0 in this position times x to the first. So the 0 goes here. And then in the last one, that's where you put that constant of 2. That goes in this box right here. So that's the first stage in the process. At the next stage, it works like this. You take that negative 1 in the first box, and you copy it according to the arrow straight down. It comes down over here, negative 1. From here, now you do the following. Negative 1 multiplied by negative 2. That output goes in this box right here. So that would be positive 2. So again, you take the negative 1, multiply by negative 2. That gives you positive 2 in that box. At the next stage, let me erase the arrows so the work doesn't get too cluttered. At the next stage, you add straight down this way. So you do 2 plus 2, which is then 4. That goes as this entry in this box right here. And it's the same as when you write it by hand. Then at the next stage, let me erase this. You take the 4 and you multiply again by negative 2. So that x that I'm writing here is really meant to be multiplication. So you're doing 4 times negative 2. That gets put in this box. So it becomes here negative 8. So now I do again, I add straight down. The 2 plus the negative 8, that's going to give me negative 6. That goes in this box right here, negative 6. And I erase the lines. You got to keep things clean here. Let me erase. You can't have all of the lines there, obviously. And then I continue. Let me erase these little arrows here also. Then I continue. So now again I do negative 6 times that negative 2. That tells me that in this box right here, I put the product. So negative 6 times negative 2 will give me positive 12 in this box. Positive 12. And then as before, I add straight down. So it's going to be 0 plus 12. That's going to give me positive 12 in this box. Or in that position if you like. Then I'm going to erase the arrows. Let me erase the arrow. Let me erase the arrows here. Next stage, I repeat one more time. So it's going to be 12 times that negative 2. That's going to give you negative 24. You're going to take that value and put it in this box right here. So again, 12 times negative 2, that's negative 24. You put that in this box right here. It's negative 24 in that box. Let me erase the arrows. Let me do that right now. The picture. And now, you add straight down this way. So you have 2 minus 24, which will then give us negative 22 in this box, okay? Since you're doing polynomial division, I'm assuming you've done regular division of polynomials, so that means this negative 1 right here on the bottom row, that represents the coefficient in x cubed. So you put, it's as if you did negative 1 times x cubed. That 4, that represents the coefficient on the following, on x squared. So it becomes 4 times positive x squared. That negative 6, that's the coefficient on just x. And that 12, that's just a constant. Notice that on the bottom, it's again arranged from highest to lowest, isn't it? It's x cubed, x squared, x, and then a constant. That last value, that's the remainder. So often, to attach the remainder, you write it in this form. You put the negative 1x cubed plus 4x squared minus 6x plus 12. And then you put the remainder over the divisor. So you put minus because the remainder is negative. If the remainder were positive, you would put a positive, for example. In this case, it's negative. You put the remainder of negative 22 over the divisor. The divisor is this thing right here. Okay, so that's the divisor, the original divisor. So that there will be x plus 2, like that. You don't need the parentheses. If you're in my class, please be careful when you enter this, because it has to go into this box right here. So when you enter it in the box, you type it as follows. Negative, for example, x cubed plus 4x squared minus 6x plus 12 minus 22 over x plus 2. So the division symbol, because it becomes the forward slash, and then you put the divisor after the slash. And make sure you enclose the divisor within parentheses. And then that works. For those of you who are interested to know why here this should be an x cubed, well, think about the following. Whenever you divide polynomials as a reduced or a simplified example, think of it. Imagine I gave you x to the 4th divided by x. Well, that's x to the 3rd, isn't it? You see how that's already, this here is 1 smaller than the 4. Synthetic division is called that because it's a more efficient way of doing polynomial division. There are websites that explain why synthetic division works. Okay, that's not necessary for our purposes. Thanks so much. I'll see you in another video.